Assalamualaikum and a very good day to everyone. Welcome to our video, Understanding T-Test. Before we begin, allow us to introduce ourselves. I am Nur Hafiza, and together with my group members, Auni Nabila and Ain Soleha, we will be explaining the topic of T-Test. So what exactly is a T-Test? A T-Test is a statistical test used to determine whether there is a significant difference between means. So in other words, it helps us to decide whether the differences we observe are genuine or whether they simply occurred by chance. So the T-test is commonly used when the sample size is relatively small, usually less than 30, and we use T-test when the population standard deviation is unknown. It is based on the student t-distribution and is widely used by researchers to make conclusions and decisions based on sample data. So therefore, instead of relying on assumptions or intuition, the t-tests actually provide a more objective way of analyzing data. So in simple terms, the t-tests help us to answer one important question. Are these differences real or did they happen simply by chance? So why do we use t-tests? So in research and everyday life, we often need to compare groups and determine whether there is a meaningful difference between them. For example, we may ask questions such as, does medication reduce the blood pressure? Does a new teaching method improve scores? And are male and female heights different? So, rather than making decisions based on assumptions, t-tests can actually allow us to make objective decisions using data and statistical evidence. And because of this, t-tests are among the most widely used statistical tools in many fields, such as education, medicine, agriculture, and also business. So there are three main types of t-tests, and each type is used for different situations. The first one is one sample t-test, and this test is used when we want to compare the mean of a sample with a non-population mean or a standard value. For example, suppose a company states that the average lifespan of its light bulbs should be 1005 hours plus or minus 10 hours. However, a new batch of light gave 995 hours plus or minus 5 hours. So one sample t-test can be used to determine whether the observed difference is actually statistically significant and whether the new batch falls below the required standard or not. Next is the independent or unpaired t-test. So this test is used to compare the means of two unrelated or independent groups. For example, we may want to compare students who learn through traditional learning with those who learn through online learning. Since the individuals in both groups are different and unrelated, so these groups are considered independent. Therefore, an independent t-test is used to determine whether there is a significant difference between the mean scores of the two groups. And the last one is the related or paired t-test. So unlike independent t-test, this test involves measurements taken from the same subjects at two different times. For example, researchers may compare blood pressure before and after medication or body weight before and after taking supplements. Since the measurements are obtained from the same individuals, so the observations are considered related or paired. So therefore, a paired t-test is used to determine whether there is a significant change after treatment or intervention. Although there are three different types of t-tests, this video will mainly focus on the independent two-sample t-test, which is one of the most commonly used statistically tests in research. So as mentioned earlier, this test is used to compare the means of two independent groups and determine whether the difference between them is statistically significant. And in the next section, my teammate will explain the concept and assumptions that must be satisfied before performing the independent two-sample t-test.
To use an independent t-test, you must first have two independent groups, which is a continuous numerical data. Then you must set hypothesis, set its significance level, and satisfy these assumptions, which is independence, normality, and equivariance. Set up hypothesis, there's two, which is the first one is no significant difference and significant difference exists. Set significance level, or statistically called alpha, which is the best value to use, is 0.05, where when p-value is less than 0.05, meaning that there is less than 5% chance that the results are statistically significant. And when p-value is bigger than 0.05, meaning that there is a high probability that the results are statistically not significant. Assumptions. There are three assumptions that needs to be satisfied, which is the first one is independence, where the sample must be independent, meaning that the two sample or groups must be unrelated. Variable being compared must also be quantitative. Normality. You must first check for normality or bell shape by using histogram or Shapiro-Wilk test. So if the p-value is bigger than 0.05, meaning that the normality is assumed and the data is normal. Third one is equal variance. Similar spread, meaning do both groups have similar variability? How to check? You can use box plot, Leven's test. If the p-value is bigger than 0.05, meaning that the equal variance is assumed. When all three of these assumptions have been assumed, then you can continue using the independence t-test. And there are also ways to visualize the data, whether it's normal or not, where you can use histogram to visualize its normality, box plot to visualize its equal variance, and dot plot to see overlap between the data.
So next, we move to our software demonstration. So I will demonstrate how to do t-test in Excel and the step to achieve t-test output. So let's see our example dataset. So for our example dataset, in this study, we want to investigate whether the method of learning affects student academic performance. So specifically, we are comparing the examination scores of students who learn through traditional face-to-face learning and students who learn through online learning. So as shown in the table, we collected exam scores from 20 students in traditional learning group and 20 students in the online learning group. So these two groups are independent because each student belongs to only one learning method. So there is no overlap between the group. So before conducting any statistical test, it is important to clearly define the research objective. So our objective is to determine whether there is a statistically significant difference in the average examination. So between the two learning methods. So to answer this research question, we will use an independent two example t-test because we are comparing the means of two independent groups. Okay. So now let's see. So this is our Excel. So the first is we have to do is hypothesis. So next we formulate our hypothesis. So as we can see, there will be two hypotheses, which is the first one is null hypothesis and the second one is alternative hypothesis. So the null hypothesis denoted as HO. It states that there is no significant difference in the mean exam scores between students who learn through the traditional learning and students who learn through online learning. So this means that any observed difference in score is assumed to be random variation. So the next is alternative hypothesis. Alternative hypothesis denoted as H1, which states that there is a significant difference in the mean exam scores between the two groups. So this means that the learning method may have an effect on students' performance. So we will test this hypothesis using significance level of 0.05 as the alpha. So we know that if p lower than 0.05, we reject the null hypothesis. So this is our Excel example. So now I'm going to show how to obtain the data. So this is the data we get from the t-test. Going to demonstrate how to do the Excel t-test. So the first is, of course, you have to collect the data. Just copy paste this. Okay. After we have done the hypothesis, we copy paste the data, and then after that we must do the feature test. Okay, why we have to do feature test is because the box plot will show the whether we have to use the unequal variance or equal variance. To take this. Okay, so this is for the traditional. So the next, I'm going to the next one. So as you can see, the data is quite symmetric, so we can use the t-test evade. So next, after we done the risk box plot, we can use the data analysis. This is to obtain this data output from the Excel. So the first is go to the data, choose data analyst at the data, we choose the data analyst, and then we have, okay, we choose the two sample assuming an equal variance. So after entering the data, we select the dependent two sample t-test option from the software. So the software will calculate several statistical value automatically. So does, and then we click OK. First, cancel all these, and then we insert data. First, we insert the data. Okay. So just click the labels. Alpha is 0.05. Okay, here we can just choose the place we want. So example, I want to choose here. Okay, then we click OK. Okay, now we already get the data, the output. So this is the output we get back for the first one. So we already get the output. So after running the analysis, we'll obtain the output table shown. Right, so there are three key values that we need to focus on when integrating the result. So the first value is the t-statistic. As you can see, there's 10.0, 10.529. So the t-statistic measures the size of difference between the group means relative to the variation within the group. So more larger absolute p-value indicates stronger evidence against the null hypothesis. So the next second value is the degree of freedom, which is the DF. So we get the DF is 33. So degrees of freedom are related to the sample size and used to determine the critical values and probability distributions for our hypothesis testing. So the last one, the third one is P-value. This is the most important thing. This P-value will help us determine whether the difference between the two groups is significant or not. So, but what is P-value is one of the most important concepts in this hypothesis testing. So, since the p-value is smaller than the significance level of 0.05, the difference between the two groups is significant. Therefore, the learning method appears to have significant effects on students' examination performance. So, let's see the decision rule. So, if we know it's p lower than 0.05, we reject the null hypothesis. So, the evidence of a significance difference. And if p is higher than 0.05, we fail to reject the null hypothesis. So it shows that insufficient evidence of a significant difference. So based on our result, we get the p lower than 0.01. So this means the probability that the observed difference occurred by chance is small. There is small difference between them. Therefore, we reject the null hypothesis. So, conclusion based on the result, the independent two-sample test, we found that strong evidence that the learning method influenced examination performance. So, students in the traditional learning group achieved a higher mean score of 79.8 compared with a mean score of 71 for students in the online learning group. So, this statistical analysis produced the statistic of 7.25 and the p-value less than 0.01. So because the p-value is lower than the significance level of 0.05, we reject the null hypothesis. So we conclude there is a statistically significant difference in exam scores between the student taught using traditional learning and taught using online learning to the application of the t-test. So t-test is one of the most widely used in statistical methods because it helps researchers compare the average outcomes of a different group. You can compare something. So in medicine, we can compare the treatment effectiveness. Examples such as medications, medical procedure, we can compare how the treatments can be solved. And other than that, we also have in agriculture. T-tests can be used to compare crop yields produced under different fertilizers, irrigation system, farming practice. Other than that, we also use t-tests in business. You can use t-tests in business. Organization use t-tests to evaluate marketing campaigns, employee performance, product sales, and last but not least, we can also apply t-tests in quality control, we can compare product measurement from different production methods. So this can ensure the production process meet the required standards. So because of its versatility and simple, the test is more simple. Is one of the most important statistical tools that used across many scientific disciplines, such as ESP, biochem. We use t-test. We also learn t-test. Okay, let's move to the summary. So to summarize our presentation, a t-test is a statistical method that used to determine whether the means of group differ significantly or not from one another. So the three main types of t-test is one sample t-test, paired t-test, and independent two sample t-test. So in this presentation, we demonstrated the independent two sample t-test by comparing examination scores between the student taught using traditional learning and online learning method. So we formulated hypothesis, enter the data into the statistical software, interpret the output table, use the p-value to make statistical decision. So our analysis showed that the p-value was less than 0.05. So it indicates a significant difference between the two groups. So this demonstrates how to do the statistical testing on ourselves, how can be used to support evidence-based decision making in research. That's all from us. Thank you.